Okay, I forgot to make a quiz, and I don't want to throw things off and have things due Tuesdays and Thursdays, so we'll just wait till next Tuesday to post a quiz. It will be due the following Tuesday, so there's no quiz this week. We'll get to it next week. Homework 5 was due last night. Homework 6 is due on Tuesday. That's the 19th. And since, well, I guess what I'm trying to say is I will do my best to update your gradebook as soon as possible, especially since I don't have a quiz to create or grade right now. So I'll work on your other grades. All right, we need to, or I would like to do examples for the notes we did last time, and then we need to do a little bit of factoring. So we want to talk about greatest common factor and factor by grouping. But right now, we're still in chapter 5, and I want to talk a little bit about exponents and then about working with polynomials, and then we'll get to factoring. Okay. So I don't know if we've already talked about this in class, but I do want to go over it, at least make sure that we've written it down. It's kind of easy, but just an idea that we should work through. Just powers of -1. If you have -1 to an even power, it's +1. -1 to an odd power is -1. We're going to go through the first few, like -1 squared, -1 cubed, -1 to the 4th. Your even power is going to be +1. But just expanding this, negative times a negative is that positive. Okay. -1 cubed. So let's just expand. -1, -1. First two together, this is 1. It's -1. Just -1. It's your odd power, it's a negative number after. -1 to the 4th. Negative and a negative. that's positive. Another negative times negative, just positive. So this is 1 times 1, just 1. So it's your even power, positive output, positive 1. So if we look at negative 1 to the 7th, it should be negative 1. We're not going to expand it, but I mean, you can if you want to. But you just kind of know negative 1 with an odd power, like 7. Negative 1 with an even power, like 8, would be positive. Let's do negative 1 to a power of 20. 20 is even, so the answer is positive 1. Let's do negative 1 to the 35th. 35 is odd, so this is a negative 1. And then when I have a big expression with a power on it, I do kind of single out this little negative number. You don't have to do that, but it helps me to just really break apart the problem. So I'm talking about a problem like this. There's negative 2x cubed y to the 5th. And it's all raised to the 4th. So again, some people might go right to negative 2 to the 4th, but if it's me, I take that negative number and write negative 1 and put it with power 4, negative 2. Oh, no, I got the negative. Just 2 gets the power 4. Here, going there. X to the 3rd to the 4th. And y to the 5th to the 4th. You have negative 1 with an even power, so it's positive 1. 2 to the 4th, it is 16. This is x to a power of 3 times 4. Y has a power of 5 times 4. Okay, so 1 times a number is this number, 16. X to the 12th, y to the 20th. Simplify. I think we just did this one. All right, we're at negative 3, a to the power negative 2, and that all has power 5. So I'm going to put this power on the negative 1 and also on 3 and on a with power negative 2. So I'm going to single out this little negative number and then 3 and then a with the negative 2 with power 5. Negative number, negative 1 with an odd power is negative 1. 3 to the 5th is 243. A to a power of -2 times 5. It's -10. And usually we want simplified answers to have powers that are positive. So we have to take care of that negative power, and we're also going to rewrite this just a bit better. It's -243, and we're going to put this over a to the 10th. All right, we're going to continue to simplify. AB times 1 over A minus 1 over B. So we're going to distribute AB. You want to apply it to both terms. Multiply AB to 1 over A. And then multiply AB with -1 over B. So you've got a negative AB over B. A over A is 1. B over B is 1. So what's left right here is just B and subtract A. Keep on working on simplifying. And using the distributive property. This time you're going to distribute x squared to x cubed minus 2x plus 1 over x squared. So take whatever values multiplied with the rest and distribute it to all of these 3 terms. X squared times x cubed is x to a power of 2 plus 3. Because they have the same base, and you're multiplying those these values together, so you keep it over that base and add to the exponents. Same here. -2 with x, and it has a power of 2 plus 1. And this one I'm just going to write as x squared times 1 over x, which would be x squared over x squared. First term is x to the 5th. Then subtract 2x cubed. And you can look at this as a number over itself, or you can do x with the power of 2 minus 2. X to the 0 is 1. Either way, this is a plus 1. Okay, going to look at this where we've got 3x plus 1 and add x minus 2. Okay, so when it says simplify, you're just taking that expression, copying it down, and making it easier to read. There's no equal sign anywhere. There's nothing to like add and subtract to both sides. We just want this to be an expression that hopefully has no negative exponents, is fully reduced, and have combined all like terms, all those kinds of things. All right, there's an addition sign, so you don't have to like, I mean, I can distribute the plus, but it doesn't change anything. This is just 3x minus 1. You add an x and then subtract a 2. So we want to combine like terms. You put the 3x with x, which is 4x total. And then there's a minus 1, minus 2. So we subtract 3. So I'm still gonna stick with just simplify, which kind of means like expand as much as possible and then combine all like terms. And then again, you usually don't want any negative exponents. Okay, take 3x minus 1 and just multiply with x minus 2. First, we're going to FOIL. So let's copy this down. We do 3x times x. It's 3 to the power, 3 times x. Yikes. 3 times x to the power of 2. 3x times negative 2 would be negative 6x. Negative 1 times x is negative x. Negative 1 times negative 2 would be a positive 2. Then you want to combine your like terms. So 3x squared minus 7x plus 2. Okay, I'm going to work through the same problem, but use something that's sort of on your homework, and it's also in the book, where we're going to draw a square. This also will help us in the future when we work on completing the square. So this is just another way to do that problem. So if you've got like 2 by 2, it's going to be a square. If you've got maybe 3 terms times 2 terms, it'd be more like a rectangle. So I'm going to put square / rectangle, depends on the problem. This one's going to be square. You have 3x minus 1. Kind of like 3x here, negative 1 there. Then multiplied by x and negative 2, x minus 2. And then you multiply the sides. 3x times x is 3x squared. 3x times -2 is -6x. -1 times x is -x. -1 times -2 is +2. And then your like terms are going to be across from each other right here. Just like those ones right there. So if you multiply 3x minus 1 times this x minus 2, I guess we're going to erase this. Okay, this times this is 3x squared minus 7x plus 2. Same thing. All right, let's do product, and I'm also going to use a square. X plus 3 squared. Okay, you could FOIL this out, which maybe we'll do as well, but I'm going to start with this square shape. I have x plus 3, which is going to be multiplied with x plus 3. And here, x times x is x squared. 3x. 3x. And 9. And your like terms are across from each other. So you want to add 3x with 3x to get 6x. Let's do one more. Simplify. Let's go with 4x plus 3 times 4x minus 2. Okay, you can FOIL, but I'm going to stick with using these squares. So if I'm going with the square, we take one of the factors, put it on the top, like 4x plus 3. And then on the side, 4x minus 2. 4x minus 2. Then 4x times 4x is 16x squared. 4x times -2 is -8x. Here's 12x and -6. Then you put your like terms together. Okay, we've got 16x squared plus 4x. and then minus 6. Okay, we want to look at There is a special product. We'll go with 4x plus 3 times 4x minus 3. You got 4 like this, with there's a plus sign and a minus sign. 4x plus 3, 4x minus 3. This is the difference of squares. You got your first term 4x, and then your second term 3. So you take that first term and square it, subtract the second term squared. And that's from being a difference of squares. All right, 4x squared would be 16x squared. And then you subtract 9. Simplify. X plus 7 times x minus 7. It's another difference of squares. You got your first term x plus your second term 7. First term x minus second term 7. You take the first term, square it, you subtract the second term squared. So it's the x squared minus 49. It's really nice when you've memorized this difference of squares formula, because you don't have to do any square or foiling or anything. You just kind of jump to the first term squared minus second term squared, and just rewrite that. It's quick. Okay, I want to make sure we talk about grouping, factoring the greatest factor, factoring the greatest common factor, and factoring by grouping. So let's see. All right, we should have plenty of time. All right, that means we can do some examples about dividing first. So we want to divide a polynomial by a monomial. Divide 20x to the 4th. Plus 15x cubed. Minus 5x squared. by negative 5x squared. I think it helps just to rewrite this first. Just take that first expression and put it over this one. And then we put every term from the numerator over that value in the denominator. We're going to have this broken up into 20x to the fourth over negative 5x squared. Add 15x cubed over negative 5x squared. Minus 5x squared over negative 5x squared. So just split this up into 3 pieces. First one, 20x to the fourth over negative 5x squared plus 15x cubed over negative 5x squared minus 5x squared over negative 5x squared. This 20 divided by negative 5 is negative 4. X has a power of 4 minus 2. There's a negative number here, so it makes this whole value negative. So we're going to subtract 15 over 5, which would be 3. X has a power of 3 minus 2. Then we're subtracting a negative number. So it's negative in the denominator, makes that whole number negative. So minus minus becomes plus. 5 over 5 is 1. And then, so is x squared over x squared. So this is plus 1. Cool. It's negative 4x squared minus 3x plus 1. One more, and then we're going to start chapter 6. A squared b squared c ab squared c cubed by abc. First, we're just going to write down what we need to do. Take a squared b squared c minus ab squared c cubed, and it's divided by abc. We're going to break this into 2 parts. This value over ABC, that value over ABC. We're here equals a squared b squared c divided by abc. minus AB squared C cubed, that's over A, B, C. This A has a power of 2 minus 1. This B has a power of 2 minus 1, and here is 1 minus 1. Then just copying this down. A has a power of 1 minus 1. B has a power of 2 minus 1. Which is 1. B has a C has a power of 3 minus 1. So that's A to the first, B to the first, C to the 0, minus A to the 0, B to the first, C squared. Any number with power 0 is 1. And any number with power 1 is its same number. So this A to the first is A, B to the first is B, C to the 0 is 1. A to the 0 is also 1. B to the first is B, C squared. All right, so we're in chapter 6. We're only looking at 6.1 today. And these notes from section 6.1 are still here to help you for the next homework, which is homework 6. So let's see. I've got the definition from the book, and then I did my best to try to explain it, but I think maybe like with a few examples, I can explain it better. All right, the greatest common factor. Or GCF. For a polynomial, is the largest monomial that divides each term. In the polynomial evenly. I'm going to start with an example. I think that will help me to explain like maybe steps on how to find the greatest common factor. So let's look at find the GCF. of, let's do 2x cubed and 6x to the 5th. So the greatest common factor has to divide into 2x cubed evenly, no remainder. And it has to divide into 6x to the 5th. So let's go, I'm going to piece together on the side what you need to look for as this like monomial, the largest monomial that divides every term. Just to have this. The number value of the GCF needs to have factors that are common to both terms or to all terms. So So I'm thinking like when we did least common multiple, we would factor everything and take the most of a factor. This is different. This time you would take the least of a factor, or if you have a missing factor, don't even use that in your GCF. So we'll get that here. Let's start the GCF. Okay, you check your factors. One factor is 2. The other number factors into 2 times 3. So this time you would take the least of any factor. So let's just start with 3. There's 1 3 here, no 3s here. So we're not even going to use 3 because like 0 3s is the least we would have. For 2, there's 1 2, there's 1 2, so we will use 2 as part of the GCF. So making sure that the factor is common to every single term, you're probably going to go with like the least of any factor. We're not even going to write that down. Okay, when it comes to the variable part, you pick the highest power of the variable. Wait, let me make sure I got that right. Actually, maybe the smallest power of the variable. Let's go with the smallest power. We'll do some more examples and just make sure this makes sense with the examples. But for now, if I pick the smallest power for my variable, and the variable is x, I would pick x cubed. Let's just check. Does 2x cubed divide 2x cubed? Yes. Does 2x cubed divide evenly into 6x to the 5th? Yes. Let me make sure. Let's just do that on this. Let's just do this as scratch work. So I'm just double checking I picked the right GCF. Does 2x cubed divide 2x cubed? Well, 2x cubed divided by 2x cubed would be 1. And does 2x cubed divide 6x to the 5th? Well, if you have 6x to the 5th divided by 2x cubed, you would get 3. X has a power of 5 minus 3, which is x squared. So this is good. Okay, let's find the greatest common factor. Two a cubed b to the 5th. Minus 4a to the 7th b squared. Plus 8 to the 6th. Okay, so I'd factor all of the numbers. 2 is fine. 4 would be 2 times 2. 8 is 2 times 4. 4 is 2 times 2. For the greatest common factor, the number has to be common to all terms. So there's a 2 here, there's a 2 here, there's a 2 here. Then you pick the least. So you've got 3 2s, 2 2s, or 1 2. Pick the just 1 2. The smallest value, like the smallest number of 2s you have. For a, we're going to go with the smallest power. A cubed, a to the 7th, a to the 6th. So we're going to use a cubed. And when it comes to b, there's b here, b to the 5th. There's a b squared in the middle. The last term does not have b. So the least you have of b is none of them. So don't even use b in your GCF. And then just final check before we move on. Does 2a cubed divide each of these 3 terms? We'll do it as scratch work. Okay, we'll just divide them all, make sure we don't have any remainders or anything. And then we're going to start factoring out the greatest common factor. Okay, just making sure that this divides that term, and that term. Actually, I don't need these symbols in the middle. I just wanted to separate this like a list. This value, comma, that expression, that one. Okay. Check on 2a cubed b to the 5th divided by 2a cubed. 2 over 2 is 1, a cubed over a cubed is 1, and what's left over is b to the 5th. And take 4a to the 7th b squared. Does this divide into that evenly? Four over 2 would be 2. A has a power of 7 minus 3, which is 4. And then b squared. Just check that 8 to the 6th divided by 2a cubed doesn't have any like weird remainders. Like it divides evenly into 4a with the power of 6 minus 3, which is 3. All right, so what we really want to do is factor out the greatest common factor from a polynomial. Five x cubed plus 15x squared. Okay, first I just want to find the greatest common factor. Greatest common factor. Well, let's factor the numbers. The first one's fine, 5. 15 would be 3 times 5. So for the number part, you do have 5 common to both terms, and the least you have of 5 is just one of them. Okay, there's a 3 in this term, but there's no 3 over here, so we're not going to use 3. For x, use the smallest power, x squared. Okay, so we're taking 5x cubed plus 15x squared, and we factor out 5x squared. So you're taking out the 5, you're taking away 2 from this x cubed, which leaves x to the first, or just x. Then factoring out 5 from 15 leaves 3. And you factored out the x squared to the front, so that's all that's inside. And if you ever want to check your work, you would just try going backwards, go from this step back to this step by distributing that number here and here, and just make sure they're equal. If you go here, you get back to 5x cubed. Multiply to there, there's your 15x squared. Factor out the GCF. Let's go with it's 6x cubed y minus 18x squared y squared plus 12xy cubed. First, we just want to find the greatest common factor. means I need to factor all of the numbers and then find the least of any factor. Okay, 6 is 2 times 3. 18 is like 2 times 9. 9 is 3 times 3. 12 would be 3 times 4, and 4 is 2 times 2. Okay, so your factors have to be common to all terms, where we've got 2 here, and a 2 here, and a 2 here. Okay, then you use the least of your 2's. There's 2 2's here, there's 1 2, there's 1 2. I only need 1 2. For 3, there's 1 3, 2 3's, 1 3. So just like 1 3. For your x, you go with the smallest power. This has x cubed, this has x squared, that has just x. So we'll pick plain old x. All right. For y, and all of this is multiplied together, by the way. For y, there's 1y, a y squared, a y cubed. Go with the smallest power, just y. Okay, then we're going to take this and factor it. 6x cubed y minus 18x squared y squared. Add 12xy cubed. And we factor out 6xy. And then work on it term by term. We've taken the 6 away. You take one of the x's away, which leaves 2 left over. And x squared stays behind. And you factor out the y. So we've done that part. Then you minus 18 divided by 6 would leave 3. We're taking out an x from x squared, so it leaves x. And a y from y squared leaves y. Then add 12 divided by 6 is 2. From 12xy cubed, we factor out the x, so there's no x right here. We've taken it out to the front. From y cubed, we factor out a y, which leaves y squared. And again, if you want to make sure that from this step to this step, you made all the right choices, you would just distribute this back out and it would go back this way. So if you want to go, if you distribute this and it equals that, then you've just gone back one step, just to double check your work. That's the only reason why you would do that. Otherwise, we're done. This is the answer. Factored that polynomial. Okay, I'm going to try to think of one more, and then we want to talk about factoring by grouping. Okay. Factor out the greatest common factor. from 2x cubed y plus 10xy to the fourth minus 2xy. Let's find the greatest common factor first. That's scratch work. Oh, we're just going to put GCF. Okay, start with the numbers and factoring them. There's 2, which is 2. 10 would be 2 times 5. And then there's another 2. Okay. So you check out your factors, and it has to be common, the greatest common factor, to all 3 terms. There's a 2 here, there's a 2 here, there's a 2 here. You're going to use 2. There's no 5 in this part, so we're not even going to use 5. Even though there's a 5 as one of the factors, the least you have of 5 is none. For your variable x, use the smallest power. X cubed, just x, plain x. For y, there's just y to the fourth, y. So y to the first is our choice. Okay, we want to factor that out of the polynomial. We'll copy down to get started. So factoring 2xy out of every term. We're taking out the 2, so we're done. We're taking out an x from x cubed, which leaves x squared. And we're taking out the y. In the middle term, factor out 2, which leaves 5. Factor out the x, so there's no x value to worry about. And from y to the fourth, factor out 1y, and it leaves y cubed. Minus the 2 is factored out, the x is factored out, and the y is factored out, so we minus 1. And this is the answer. You wouldn't want to, the only reason why you would distribute this value out is to check if the previous step, if what you've done from that step to the other was correct. So if you distribute this, you'd get the first term, distribute that, you go back this way, distribute here, it should match it. Okay, last thing we need to talk about today is factoring by grouping. So if you can't find a greatest common factor for every term, see if pairs of terms can be factored. pairs of terms. Like you take two terms and pair them together. And then try to keep factoring. We'll practice. Some problems will just say factor. There's going to be different ways you can factor. Either you're going to factor the greatest common factor, you can factor by grouping. Let's see, where's it? We're going to work on completing the square soon. So there's a list of tricks to use depending on like the problem. Okay, I think I need to check the book for some examples. So bear with me while I pull up our digital book. Okay, here we go. We're going to take AB plus 7A minus 3B minus 21 and factor it. So sometimes it might help to rearrange your terms a little bit. This time I think we can just pair them up if we want to. So I might just try putting like this term that has A and this term that has A, put them together. These both at least have like a -3 in common. So we're gonna try factoring this way. All right, so just rewrite what we've got. Okay, first pair, we're gonna factor out A from just the two terms in the front. So it leaves B plus 7. Okay, from the next pair of terms, this has a -3 and this has a factor of -3. So I want to factor out -3. -3 factored out from the first term leaves B. And then factor out -3 from -21, it would leave positive 7. Okay. So now this whole first term minus this second term, the two terms have B plus 7 as a common factor. So from this term and this term, factor out B plus 7. From here, if you take away the B plus 7, it leaves A. And then you've taken care of this piece, minus. From this part, take away B plus 7, it leaves that 3. And that's the answer. Okay, so let's practice a couple of these. Factoring by grouping. Let's try, actually, you know what, we're out of time. So we'll try a few more when we meet next time on Tuesday. But overall, this should be enough for you to do your homework. Maybe a few more factoring by grouping problems would help, but we're out of time. So thank you, especially to those of you who are in the meeting right now. I really appreciate it. And I hope you have a good weekend. Okay, we're done.